In this video, we're going to see the factors that affect the rate of a reaction. But first of all, what does the rate of reaction mean? The rate of reaction means the speed of different chemical reaction happen. Some reactions are very fast and others are very slow. The speed of reaction is called the rate of the reaction. And the rate of reaction depends on two important things: the frequency of collision between particles and the energy with which the particle collides. The rate of reaction depends on different factors. Some of those factors include the temperature, the concentration of dissolved, and the pressure of the reactants, especially when you have the gaseous reactants, the increased surface area of the solids, and the use of catalyst. So in this video, we will see about the effect of temperature, the effect of concentration, the effect of pressure, and the effect of surface area. In chemistry, when we say the rate of reaction, it means the speed at which the reaction takes place. Some reactions are slow, others are fast, but all reactions can be manipulated in such a way that they can be slowed down, they can be increased, the rate can be increased up. So there are different factors that can affect the reaction rate, and we are going to discuss each one by one. So let's explore how the concentration can affect the reaction rate. When increasing the concentration of the reactant speeds up the reaction rate. Let's imagine the synthesis reaction between two molecules. For example, A reactive B to produce AB. Let's say that we increase the concentration of A. That means there are more molecules of reactant A per volume, so the reactant is more likely to collide with reactant A and produce the reaction. More collisions equal fast reactions. So you can see, for example, in these two reaction vessels, for the first case, you see because the concentration of the reactant is small, it's harder for the green molecules to make collision with the blue molecules. But when you increase the concentration of blue molecules, it made them more likely for the green molecule to make a collision with blue molecules. The second factor is the temperature. The increasing temperature also increases the reaction rate. Temperature measures the system's average kinetic energy. So raising the temperature increases the kinetic energy of the molecules. The more the molecule moves fast inside the container, then the more corrosions, and the more corrosion creates the fast reaction. For a reaction to occur, the corrosion needs to overcome activation energy. With more kinetic energy, the molecules are likely to overcome the barrier, so the rate of reaction increases. So let's see what is happening in this reaction vessel. The molecule in this reaction are moving very slowly, which means that it is harder for collision to occur. This causing the reaction to proceed at a very slow rate when the temperature is low. But what happens when increase the temperature? let's see the second vessel. When the temperature is increased, the kinetic energy of the molecule will increase also, thus causing the molecule to move faster, which causing corrosion to occur more frequently, and more corrosions mean the reaction rate increases. The third factor is pressure. Let's see, for example, in the first reaction vessel, we all have the large volume, which means the pressure is low. Those two reactant balls, one for green, other for blue, because the volume is very large, the molecules in this reaction need to move and bounce multiple times before making corrosions. This means that there are not a lot of corrosion happening, which makes the reaction rate slow. But when you increase the pressure, it means you have reduced the volume. And you can see, for example, these down arrows are indicating that the piston is being pushed down, hence the volume is reduced. When the volume is reduced, the pressure is increased. By increasing the pressure, the molecules are able to have a corrosion at a lot easier than before, thus causing the number of corrosions to increase. The fourth factor, the surface area. Let us imagine an ionic compound such as sodium chloride, for example. Well, we know they form the crystal lattice, so we have the repeating unity cell of ions that build the overall structure. But that means some of the ions are buried inside the crystal. Only the ions on the surface can react. Let's imagine we took an ionic crystal and smashed it with a hammer. That would be a lot of fun, but could expose some of the ions in the center of the crystal. Now they can react. Increasing the reactant surface area exposes the reactive the particles or species, so the reactant are more likely to successfully collide. When the reactant has a similar surface area, it is harder for the reactant to interact. There are fewer successful corrosion. So increasing the reactant surface area increases the reaction rate. Well, we can see on those two presentation. The first one, we can see the surface area of the pink compound is too small. As you can see, a few of the pink ions or pink molecules are on the surface. It means those on the surface are the only molecule that can react. The molecule insides are not able to interact with the blue molecules outside. But when we break down the pink compound, it means we have increased the surface. Now you can see the molecule out, the molecules which were in the center of the compounds are now reacting with the blue compounds. In this case, there are more corrosions and the rate of reaction will be very fast. Different factors affect the rate of chemical reaction. Those factors include the concentration, the pressure, temperature, and the surface area. Thank you for watching this video, and I hope you enjoyed the video. Thank you. Bye.